Intel unveils 5G modem suite. Intel's 5G and LTE roadmap. Intel has unveiled its 5G new radio, 5G NR, modem suite, the XMM8000 series, with the first modem to be made commercially available in mid-2019. The XMM8060 will have multimodal functionality, meaning it will support non-standalone, NSA, and standalone, TSA, configurations for 5G, millimeter wave, M-wave, and sub-6 GHz spectrum bands, and legacy mobile networks. Initially, when 5G networks are deployed worldwide, many of the networks will start with non-standalone configuration, although some operators may choose to start with standalone and eventually migrate to standalone. It's important for a commercial device from day one to support both network configurations. Chen Weiyan, VP and GM of Connected Products at Intel Client Computing Group, explained in a call with media. The second element to the multi-mode story is that we support, in addition to 5G, the various 2G, 3G, and 4G legacy air interface modes. And this is significant because for operators, from day one at least, there won't be ubiquitous 5G coverage, and in places where 5G coverage is not available, the device still has to work. Also announced by Intel was that it is now able to make 5G calls over the 5G modem it announced at Consumer Electronics Show, CES, 2017, codenamed Gold Ridge, using the 28 GHz spectrum band. The Intel 5G modem that we announced earlier this year, the chipset is up and running in our labs. We've been using it for testing purposes and we've made successful calls over 5G now with this chipset over 28 GHz. Alex Quach, VP of Network Platforms Group and GM of Intel's 5G Strategy and Program Office, said. The CES modem was the first to support M-wave and sub-6 GHz spectrum bands, incorporating massive multiple input multiple output, MIMO, beamforming technology, and advanced channel coding, supporting speeds of over 5 Gbps and ultra-low latency. Intel's Gold Ridge 5G modem. The modem also integrates with Intel's 28 GHz 5G radio frequency integrated circuit, RFIC, as well as its 4G XMM7360 LTE modem for 4G 5G interworking. Intel also used the call to announce its XMM7660 modem for 4G LTE, which it said supports beyond gigabit speeds using MIMO and carrier aggregation, while also revealing that its previous generation 7560 modem is now attaining 1 Gbps speeds. We're announcing the next generation Intel LTE chipset, the XMM7660 model, and it supports speeds of up to 1.6 Gbps. The chipset is also available in 2019, Quach said. The Intel XMM7560 modem, the one that we announced at Mobile World Congress this year, is now achieving gigabit-plus speeds. According to Quach, Intel's play in advanced mobility standards and 5G extends beyond its modems. However, 5G is so much more than just a faster modem or a new air interface. Modems are important, but they're just one piece of the 5G solution. Just like 5G needs a new modem, 5G also needs a new network. He told media. There is already transformation happening in this network. Intel doesn't just play in the modem space. We're not just interested in delivering leadership modems, we are also a key player in the network infrastructure space, from the radio access network into the core network, into the cloud, and we're working with major service providers around the world, whether it be in Korea, in China, and elsewhere, to transform these networks so that these networks become more flexible, much more efficient, and more intelligent to support 5G. Last week, Intel announced that a 5G trial with NTT Docomo, Ericsson, Denso, and Toyota attains speeds of 1 Gbps 600 megabits per second for 4K video streaming in a connected vehicle traveling at 30 km per hour using Intel's Go 5G automotive platform, an onboard antenna head. This accomplishment marks the first 5G multi-vendor interoperability trial involving a device connected to a base station in an automotive environment, the company said. Intel last month also announced that it will be providing its 5G mobile trial platform for the 5G network being deployed by Korea Telecom, KT, for the 2018 Pyeongchang Olympic Winter Games. Under the agreement, it will also provide its processors to power edge and core computing capabilities, as well as its 5G technologies including FlexRAN. Intel's third-generation 5G mobile trial platform was unveiled in September, following its first 5G trial platform in February 2016. The first platform had supported sub-6 GHz and wave spectrum, with its second-generation platform integrating 4x4 MIMO launched a year ago. The new platform allows for device development by supporting initial 5G NR specifications in live tests with partners by the end of this year, which will then be developed alongside 3GPP standards. It is powered by Intel's Field Programmable Gate Array, FGPA, circuits and Core i7 processors. At launch, it will support